Hello, and welcome back, I guess. This is going to be, we're going to start doing lesson 3.6, so that's going to be on this video. And just a brief recap of what we've done so far. I see that I do post in kind of, sporadic block intervals. And hopefully I'm hoping to get a more regular schedule going where I can post like one or two lessons a day. So if you're keeping up, but I'd like the idea is like you're hopefully doing some work on your own, and you're looking to these videos for the parts that you don't necessarily understand or you're having some difficulties with. So that's what they're for. And again, a brief recap of what we've done so far. We've the main idea behind the two important things that we learned, I guess, are the new partial factored form that we have, and the idea behind how we use symmetrical points in order to how we use symmetrical points in order to find the vertex of a parabola. So with partial factoring, finding symmetrical points, you take the average of the x values and you get your x coordinate of the vertex or your axis of symmetry, and then you substitute that value into your original, your equation of the parabola, and you get your vertex. So the kind of idea of symmetrical points, what they are points whose x values are equidistant from the vertex and they have the same y value. So that's what symmetrical points are. We've found maximum minimum values by using symmetrical points, which we thought was, which hopefully was the easier way. And then we also looked in detail about completing the square. We talked about the theory behind completing the square, and essentially we talked about the 5 steps that we require in order to complete the square in almost any case. So the theory behind completing the square is there. Hopefully we're okay with that. And we did a little bit of radicals, which was useful for us because when we get to solving quadratic equations, which was our previous lesson, we have to do radicals either using the completing the square method, or in the case of the quadratic formula method, we need radicals. So that's why we kind of spent the lesson working on radicals. And hopefully now we know how to solve quadratic equations using completing the square method. This method, the quadratic formula method, is an older method that we used to solve quadratic equations. Okay, so sorry, I just needed to quickly check something. Curiously, I probably would have pointed this out if I was we were actually having class, but this quadratic formula, it seems like it just came out of nowhere, negative b plus or minus b squared, square root of b squared minus 4ac over 2a. But interestingly, if you are willing, you could probably even Google this, but if you are willing to give it a try, I would recommend starting with, let's start with ax squared plus bx plus c equals 0, which is a standard form of a quadratic, and follow these exact 5 steps that we do to complete the square. Instead of numbers, keep those a, b, c values and try completing the square using those values. So our first step would probably be factor out an a. You get x squared plus b over ax, and when solving for x, we know we move the c to the other side. That's step 1. Step 1.5 is divide by a if possible. So you get x squared plus b over ax equals negative c over a. And then you can continue. So step 2 is finding our magic number, so to speak. So take b over a divided by 2 is b over a times a half equals to b over 2a, and then we take the square of that, b squared over 4a squared. Hopefully we're good with that. And then you can see here that I will add and subtract that in step number 3. x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared equals negative c over a. I'm going to continue up here. Step number 4 is moving this to the other side. And I'm going to combine a couple steps here. I am going to group these, and I'm going to put x plus b over 2a squared. And again, I mentioned, I think, at the end of the previous video, but hopefully we're okay how I'm getting this number in here. I just half or square root this term, and I basically get the number that's going in there. If I square root this, I get the number that's going in here. So hopefully we're seeing how I get this number. Also, you'll see that it's the same number that I took over here, because that's what I squared and added and subtracted. So it all leads back to this number and the theory behind completing the square. That's how I got that number there. Just a brief recap. Again, when I group the first 3 terms to put the whole square, like x plus something, the whole square, that something, or the second term here, is obtained by taking the square root of whatever I added and subtracted. Or as soon as you have your middle term, you divide that by 2. That's the number that we have. That's the number you have to add or subtract to x inside the bracket square. And I'm going to move this to the other side, so it becomes plus b squared over 4a squared. So x plus b over 2a squared equals, common denominator is 4a squared. I have times 4a times 4a, and you can kind of see my thing forming. I have b squared minus 4ac. Now I proceed to take the square root of both sides. I get plus or minus here. And you can continue this work if I move, so I'll get x plus b over 2a, and then if I move this to the other side, I get negative b over 2a. So you kind of see this forming. I have a negative b if I move this to the other side. I have a b squared, or I have a square root of b squared minus 4ac over here, divided by 2a, because I can take this out of the square root, and things like that. So again, it's not necessary for you to know this, but the idea is that realistically, this quadratic formula is like derived by completing the square. I just didn't pull it out of nowhere. This is the main technique that is used to kind of solve for x-intercepts, and quadratic formula is just a formula that kind of uses completing that has already done all the hard work of completing the square and just gives you the formula for it. Because realistically, as we've just seen, the quadratic formula is just completing the square. So, sorry, that was a bit of a long introduction, but we're going to move on to solving quadratic equations part 2. And again, there's a bit of homework. This isn't that big a lesson, so I decided to give a bit of preamble. But I say it's not big because it's just 2 questions, but these 2 questions are, as you hopefully can see, are not the easiest questions in the world. But nevertheless, using the tools that we have learned, they're not going to be too hard for us. Because okay, let's look at part A. I have some complicated things here, and I have to solve for n. So first thing I'm going to do is, okay, like I have n in the numerator, n in the denominator. I kind of don't like this mess, so I'm gonna group all the n's into one n. So what I'm gonna do first is I'm actually gonna bring everything to one side. You can do this or not do this; it doesn't really matter. But n plus 1 over 2 minus n minus 1 over 3n minus, I'm gonna bring that whole thing over here, so I'm going to change that to a subtraction. So again, it was like this group A minus B equals C. So if I just bring C over to this side, it becomes a negative C, or I subtract C and I get this expression equals to 0. And now I kind of want to solve for n, so I do have to find a common denominator because I can't really do anything and the numerator if I don't have a common denominator. So hopefully before we take a common denominator, we will acknowledge that n not equal to 0. We have to state restrictions. And here the only restriction is that n is not equal to 0 from this and this expression. But we could do that at the next step, because realistically we should be doing it at the next step, because after we find our common denominator here happens to be 12n, right? That is my common denominator. And so I multiply this by 6n, so this gets multiplied by 6n. I multiplied this by 4, so this gets multiplied by 4. I multiplied this by 3, so this gets multiplied by 3. I'll actually put the 4 in front of here, so I can take care of whoops, that was a big... I can take care of 2 birds with 1 stone. I'm going to multiply both n minus 1 and 2n plus 3 by -4 and -3 respectively. So I'm kind of multiplying it to get a common denominator, and I'm distributing the minus sign into the bracket, which is a very important step. You can't forget that. So let's do the math here. So 6n squared plus 6n minus 4n plus 4, very important, because the subtraction sign applies to both the n and the -1. And then here as well, the subtraction sign is going to apply to both. So this is going to be minus 6n minus 9. And all this is going to be equal to 0. So of course, here again, my restriction, I will state that n not equal to 0 as soon as I have one denominator. And then I'm going to simplify this. So I see plus 6n minus 6n, those go away. So I'm left with 6n squared minus 4n minus 5 divided by 12n equals to 0. And from here, the work gets significantly more simple, I should say, because I can just, take this 12n over to multiply both sides of this equation by 12n. And this does make an n disappear, but that's the importance of the restriction. If n equals to 0, you can't multiply both sides by 12n. Because after you multiply both sides by 12n, you get 6n squared minus 4n minus 5 equals 0. And this looks like it has no restrictions, but that's because you have multiplied both sides by 12n. So it's important to state restrictions here, because after here, your restrictions are going to disappear and you're not going to have another chance to state them. And it's important to state them. So therefore we will state that there. But now, after all this work we have done, which is hopefully familiar to everybody since we have worked on this extensively in the previous unit, hopefully now this becomes a lot easier, because now I can just use my usual completing the square kind of technique. So the first step is to factor out the 6, so 4 over 6n. I'm going to move the the minus 5 to the other side to make it plus 5 here. Step 1.5 is to divide both sides by 6. So I get n squared minus 2 over 3n. I am going to simplify the fraction. Equals 5 over 6. Oh, 5 over 6. Okay, step 2. Let's find the magic number. Negative 2 over 3 divided by 2 is negative 2 over 3 times a half, which is cancel, negative 1 over 3. I'm going to take the square root of that and get 1 over 9. And it's important to note here that whatever I'm taking the square of is my complete square, right? And we'll talk about that again. But I'm going to add and subtract this 1 over 9 to both sides. So let's see how that goes. Step 3, I'm going to do up here. Or actually, I'll do that down here. Minus 2 over 3n plus 1 over 9 minus 1 over 9 equals 5 over 6. I'm going to move the 1 over 9 over here. So step 4 is n squared minus 2 over 3n plus 1 over 9 equals 5 over 6 plus 1 over 9. And then I'm going to do two things in step 5. I am going to, I'm not yet at step 5. I'm still finishing up step 4. And okay, it doesn't really matter what you call step 5 and step 4. The idea is here you have to make this into a perfect square. So the perfect square is obtained by taking the square root of this, so that's n, and taking the square root of this, which is 1 over 3. And because this is a minus sign in between, you're going to put a minus 1 over 3 squared. And we have to simplify this as much as possible. So 9 and 6, common denominator 18, times 3 is 15, plus 2 is 17. So hopefully we're good there. And now I will proceed to take the square root of both sides. N minus 1 over 3 equals square root of 17 over 18, which is n minus 1 over 3 equals plus or minus, I should have the plus or minus here, square root of 17 divided by 18. I'm going to see if I can simplify that any. I think I should be able to. So 18 is 9 times 2. So I'm just going to work with this side a little bit. So plus or minus square root of 1 over 9 times square root of 17 over 2 is what I have. Square root of 1 over 9 is 1 over 3. So 1 over 3 square root 17 over 2 is what I get. Here, once I write that, I can kind of split. Oh, well, I can write it like this. Yeah. And now I can. This looks funny. Sorry, I just had to check something quickly. So if you look at the solutions that are posted, there is a kind of it's done a bit differently. As you can see, it's the same answer, but here we have made this 34 over 36 so that we could take the square root of 36 easily. It doesn't matter which way you're doing it, you will in the end obtain the same answer. So we're going to continue doing what we're doing here. And here we're going to say n equals positive square root of 17 divided by 3 root 2 plus 1 over 3. And it's also equal to negative root 17 divided by 3 root 2 plus 1 over 3. So this is a bit interesting. Realistically, there's no way to simplify this, so I'm actually going to leave it as a plus or minus. But what I do have to do here is I have to rationalize this guy, which is actually going to give us the answer back in the thing. So we remember how to rationalize. Hopefully, to rationalize, we have to multiply both numerator and denominator by whatever is bothering us. In this case, it's the square root of 2. And here we get, so square root of 17 times square root of 2 is square root of 34. And divided by root 2 times root 2 is 2. 2 times 3 is 6. So this square root of 17 divided by 3 root 2 is actually plus or minus root 34 over 6, which is actually what we're going to write over here instead of this mess. Just because we prefer any radicals in proper format, which means that there's no radical sign in the denominator. So positive square root 34 divided by 6 and negative root 34 divided by 6. Now, I mean, I guess you could take a common denominator and say this is 2 plus root 34 over 6. Actually, you should. And this again is times 2. So this is 2 minus root 34 divided by 6. So these are our two answers, and this is what we get. This is our n equals to this or that. So again, a bit complicated. I did it a bit differently, but I hope more intuitively than the answer key. So hopefully all of you are following along either this or the answer key method. I realize I took way too much space for this question. So I am going to erase some things, I guess. Or I'll just write really small for the next one. Okay, let's look at this question, which is kind of similar to our previous unit, at least the first steps as usual. I am going to have to factor this. So I'm going to start off with 5x minus 2 plus 6. Let's see, two numbers that multiply to positive 8, add to negative 6, so that's to be negative 4 and negative 2. So I'm going to get x minus 2, x minus 4 equals 2. I am not going to bring everything to one side because this is just a, I probably should bring everything to one side because it doesn't matter which step you do that in. The idea is here I don't have an n or an x right away, I just have a 2, so I'm going to keep that on that side and see what happens. But in the end, I do need to take a common denominator for everything. Or just take a you can just take a common denominator here. And what you're going to get is common denominator is x minus 2 times x minus 4. So I have to multiply this side by x minus 4, x minus 4. So here on this side I have 5x minus 20 plus 6 divided by x minus 2 times x minus 4 equals to 2. And of course here we are going to state our restrictions, x not equal to 2, comma 4. Important to carry that along with us all the way. And even here I guess I should, at the final answer, state n not equal to 0. But now, so from here, what are we going to do? We are going to simplify this top as much as we can, 5x minus 14. And now, okay, I am going to take this and multiply it to the other side because I kind of have to do that to get this 2 out and to remove the denominator. That's why here is basically the last step where we can take restrictions because now I'm removing the denominator. And so I get 2x minus 2x minus 4. And so after this, it's just fairly straightforward. We rearrange everything and then we set it to 0 and use our usual completing the square method. I already know what x minus 2 times x minus 4 is because I had previously factored that. So this is just basically going one step back temporarily because I do have to multiply all of this by 2 minus 12x plus 16. And I do have to I'm going to move both of these to this side. So I'm going to get 2x squared minus 12x minus 5x plus 16 plus 14 equals 0 because I've moved all of this to one side. So I do get 0 on that side. I am going to now simplify this. Alas, I have a 17, which is not divisible by 2, so it's going to be a little bit annoying to do, but that's okay. So again, after we get to this stage, which is again a big process to get to this stage, but as soon as we get to this stage, we know what to do. Of course, I would, if you were in class, I would tell you to put a star beside these questions. These are very likely to show up on your tests as like a big question, kind of combining the ideas from 2 units. But of course I don't still know how we're getting tested, so you can put a star beside it. Make sure you're reviewing how to do these before an exam or test whenever we get further information about how or when those are going to occur. So again, I'm going to move this 30 to the other side. I'm going to factor out this 2x squared minus 17 over 2x equals negative 30. I'm going to divide by 2 here. This is step 1.5, if you will. Dividing by 2. So x squared minus 17 over 2x equals negative 15. Now I find my magic number, which is negative 17 over 2 divided by 2, which hopefully we're getting used to the idea that divided by 2 is the same as multiplied by half. And then I'm going to take the square of that. And oh dear, what is 17 squared? 16 squared is 216. 17 squared is 289. Who would have known? Divided by 16. Okay, that's not a nice number, but you know, we're gonna go with it because I think we did everything correctly. I don't know if there's any errors here. Hold on. Sorry about that again. Just looks like we're on the right track. So here we can now add and subtract that to both sides. X plus 289 over 16 minus 289 over 16 equals negative 15. So here, of course, we are going to factor these three as usual and move this to the other side. So that's what step 4 is going to be. So again, step 4, I have to write a perfect square, and the perfect square is going to be x minus whatever this number was over here, whatever we squared. Or if you take the square root of this, what do we get? We get 17 over 4. So x minus 17 over 4 squared equals negative 15 plus 289 over 16. So I will take a common denominator here, times by 16 times 16. So 15 times 16 is, negative 15 times 16 is negative 240. And negative 240 plus 289 is 49. That's lucky. So 49 over 16, because that happens to be a perfect square. So I will take square root of both sides. X minus 17 over 4 equals plus or minus 7 over 4. And now I can kind of, break this into two. X equals, I move this to one side, so 7 over 4 plus 17 over 4. And x equals to minus 7 over 4 plus 17 over 4, which here is going to give me x equals 7 plus 17 is 24 over 4 equals 6, or x is going to give me 10 over 4, which equals to 5 over 2. So those are my answers for x. In this case over here, x equals to 6, comma 5 over 2. X not equals to 2 or 4, which is like, I guess at this point kind of obvious that x not equal, because x equals, that I've solved for x. But don't go by such, it's always good to state restrictions, because when you're drawing the graphs, remember, you will have holes in this graph, because the graph of this function over here that we've stated, it will look exactly like the graph of this function, 2x squared minus 7. It will look like a parabola, except for the fact that there will be extra holes present in our graph because of our restrictions that we state. So it's important to take note of those things. Again, I'll take a quick look at the homework's a worksheet. I don't have the worksheet on me, and I'm too lazy to download that. So if you do have any questions with any of these questions given in the worksheet that hopefully you are doing, feel free to post a comment, or just ask me, just leave a comment in the leave a comment below, and I will make a follow-up video of those questions. I will download them if necessary. But until the next video, I'll see you guys. Again, this was kind of complicated because we had a couple of extra steps to do before we got started with completing the square, but hopefully we're getting used to solving quadratic equations by completing the square at this point. So I will talk to everybody later. Peace out.